In problems 1 and 2, we're dealing with right triangles, and I drew one there. And we know that a squared plus b squared equals c squared. So number 1a says if a is 28 and b is 35, what is c? So you square 28, you add it to 35 squared, you get 2009 equals c squared, so c equals 44.8. In part B, you are given the hypotenuse and one of the legs, so the equation you would set up would be 10 squared plus b squared equals 26 squared. So 100 plus b squared equals 676. Take away 100 from both sides, and you get the square root of both sides, and you find out that b is 24. All right, number 2. Put it over here. They're saying, can the following be sides of a right triangle? Well, we have 7, 24, and 25. So the question is, does 7 squared plus 24 squared equal 25 squared? And you find that the left side is 625, as is the right side, so yes, it is a right triangle. Okay, B, they give us 8, 16, 17, so we set up the same scenario. 8, the longest side is always the hypotenuse, so does 8 squared plus 16 squared equal 17 squared? And when you square them and add them together, square 17, you find out that they don't equal, so this one is not a right triangle. Okay, 3a, we just have the same square root of 6, so we are just going to subtract 8 from 12, and we end up with 4 root 6. Part B, we have to try to simplify what's inside the square root signs. So I'm going to start by breaking up 45 into 9 times 5, breaking up 20 into 4 times 5. I'm trying to get factors that are perfect squares. And you see that 9 is a perfect square, as is 4. So the 9 comes out, when that becomes multiplied by 3. That 4 comes out, we'll multiply the 6 by 2, and we end up with then 9 root 5 minus 12 root 5, or negative 3 root 5. Part C, they're asking you to square that, which means you're going to have to multiply it by itself. And we'll FOIL this. So first times the first becomes 25, and root 2 times root 2 is just 2. Then we multiply that term times the second term, and we get minus, we multiply what's outside the square roots, and then what's inside the square roots, so 10 root 6. Then we go ahead and do the second piece, so minus 10 root 6. And the last part, plus, because 2 negatives, 4, and root 3 times root 3 is 3. So we end up with 50 minus 20 root 6 plus 12, or 62 minus 20 root 6, and that is our final. Part D, we're just going to distribute. So we take root 6 times 2 root 6. We get 2 root 6 times 6. It's just going to be 6. And then minus root 18. So this is 12 Second term I can simplify because I can make that 9 times 2. And I end up then with 12 minus this 9 comes out and it becomes a 3 root 2. And that's that answer. This problem I'm trying to get rid of the radical in the denominator, so I'm going to multiply by the conjugate. So 5 plus root 2 and 5 plus root 2. So what I've written in blue there is really equal to 1, so I'm not changing the value of my expression. So the numerator, 3 times 5 is 15. 3 times root 2 is just going to be 3 root 2. And remember, when we multiply by the conjugate, you end up with the first term squared. So it would be 5 times 5 is 25. The middle terms, when you multiply 5 times root 2 and then negative root 2 times 5, will cancel out. So really we just end up with the first term squared minus the second term squared. And since it's root 2 times root 2 is 2. So let's finish this off. 15 plus 3 root 2 over 23, and we are done. Part B, we're going to do the same thing, multiply by the conjugate. So we go ahead, 4 times root 7 is 4 root 7 plus 4 root 3 divided by root 7 times root 7 is going to be 7. Root 3 times root 3 is going to be 3. So now we have 4 root 7 plus 4 root 3 all over 4. And then you'll note that I can divide 4 out of each term, and I end up with just root 7 plus root 3. In number 5, we're solving for x. We want to first isolate x, so I'm going to do that by adding 3 to both sides of the equation. So I'm left with just root x on the left. So root x equals 8. And now I need to get rid of that square root sign, so I am going to square both sides of the equation. And I end up with x equals 64, and that is my final answer. B. In this equation, the root is already isolated, so I am now just going to square both sides of the equation. And the left side, the square root falls away, 3x minus 8. The right side becomes 16, and then I just add 8 to both sides. So 3x then equals 24, and I divide each side by 3. X equals 8. In this equation, I have 2 square roots, but that's all I have, and they're on 2 sides of the equation. So I can square both sides and just get rid of those square root signs, and it becomes x plus 5 equals 5x minus 11. I take away x from both sides, so I get 4x. I add 11 to both sides, 16. So you see from there, x equals 4. I'm going to have to do D on the next page. For this equation, the square root is isolated, so I'm going to go ahead and square both sides. It's going to require a little bit more work because you see I'm going to end up with an x squared term. So x squared will now be equal to 2x plus 3. Now I treat it just as a quadratic. I want to set it equal to 0. So minus 2x minus 3 equals 0. Hopefully I can factor it. It looks like I can. X minus 3, x plus 1 equals 0. It would get me my negative 2x, and it would get me the negative 3 times 1 will get me my negative 3. So in this case, I can say that x equals either 3 or negative 1. And I want to double check those because when I square it, sometimes I get answers that may not work. So if I plug 3 into that equation, I get, does 3 Go over here. Does 3 equal the square root of 3 times 2 is 6. 6 plus 3 is 9. That works. And try -1. I get -1 equals the square root of -2 plus 3. And we're dealing with positive square roots, so this one, because of that -1, will not work. So -1 doesn't work, just 3. Number 6, we're asked to graph the square root of x function. The parent function, y equals the square root of x, starts at 0, 0, and it goes up and it flattens out like so. Remember the domain for this function, x will be greater than or equal to 0. The range of this function, y will be greater than or equal to 0 as well. Now, what they're asked in this problem, though, was y equals the square root of x plus 4. But what happens there is this point here, 0, 0, is going to move up 4 units, and we're going to look like that. Y equals the square root of x plus 1, all underneath the radical sign. In this case, we're going to shift left 1 unit because that plus 1 is underneath the radical sign. And remember, if it's underneath the radical sign next to x, you do the opposite of that plus, you go negative. In the previous example, it was outside that radical sign, and we actually go up 4. The last one, see if I can fit it. Y equals root x minus 2 underneath the radical sign minus 3. I'm going to squish it in down here. Well, the x minus 2 means I move 2 units to the right. That minus 3 means I move down 3 units. So 1, 2, 3. So this is my new start point, and the graph looks the same, just from a different starting point.